In 1972, Gene Cernan stepped off the lunar surface, climbed the ladder of the Apollo 17 lander, and sealed the hatch behind him, the last human being to stand on the moon. Before he left, he said three words: "We shall return." That was 53 years ago. We didn't return. Not because we couldn't, because we stopped trying hard enough, because we built a space program optimized for politics instead of progress, because we let good enough become the standard when good enough was nowhere near enough. That just changed. In March 2026, NASA Administrator Jared Isaacman stood at a podium in Washington, D.C. with one word projected on the screen behind him: ignition. And what followed was not another promise, not another timeline that would quietly get pushed back every 18 months until everyone forgot what was originally said. What followed was a detailed, phased, technically specific blueprint for building a permanent human outpost on the moon. A real plan with real deadlines and real consequences for anyone who misses them. I've been through this plan in detail, and what I found is more ambitious, more technically interesting, and more strategically significant than almost anything in the mainstream coverage has conveyed. So here's what we're doing today. I'm going to walk you through exactly how NASA plans to build a moon base from the ground up, phase by phase, from the first uncrewed landers touching down in the South Pole region to a rotating crew of 4 people living on the lunar surface for 28 days at a stretch. I'll show you the specific technologies being deployed, why the South Pole matters more than anywhere else on the moon, what nuclear power has to do with surviving 2 weeks of darkness at -200 degrees Celsius, and why the most important sentence in this entire plan has nothing to do with rockets or rovers. This is not a vision statement. This is an engineering roadmap. And it starts with admitting that the old plan was broken. Think about building a house in the most hostile environment imaginable. No atmosphere, temperature swings of over 300 degrees Celsius between day and night, 2 weeks of continuous sunlight followed by 2 weeks of absolute darkness cold enough to freeze and destroy any electronics left unprepared. No supply store within 250,000 miles, no rescue service. Now imagine doing that while a competing construction crew is racing to claim the same plot of land, knowing whoever gets there first and stays writes the rules for everyone who comes after. That is what NASA is attempting, and they finally built a plan serious enough to have a real chance. The original Artemis architecture made a jump that no serious engineer could defend. Artemis II was a crewed test flight looping around the moon without landing. Artemis III was supposed to land using an entirely separate, unproven lunar lander that had never flown with a crew, never docked with Orion in space, and had never operated in the lunar environment. The risk was so high that the mission date kept getting pushed back year after year. The plan was not a path to the moon, it was a path to perpetual delay dressed up as a plan. The new architecture fixes this. Artemis III has been redesigned as a dress rehearsal in low Earth orbit. The crewed Orion spacecraft and the lunar lander will meet up, dock, and the crew will transfer into the lander to test life support, communications, propulsion, and the new lunar spacesuits. All of this happens close enough to Earth that if something goes wrong, people come home alive. Problems get solved before they become catastrophes. The lander situation has also changed dramatically. For years, it was assumed the lander would be SpaceX's Starship in a lunar variant. That assumption is now gone. Blue Origin is back in competition with their Blue Moon lander alongside SpaceX. One or both will be tested in Artemis III. And here is the part that changes everything. Winning a contract in 2022 does not guarantee a moon landing. The only thing that matters now is execution. The first company to demonstrate their lander works gets the mission. SpaceX is on notice. Blue Origin is on notice. The era of guaranteed contracts regardless of performance is over. Artemis III has a deadline of 2027. The winning lander company then has only months to complete an uncrewed lunar landing test and finalize the design for Artemis IV, scheduled for early 2028. That's when American boots return to the lunar surface for the first time since 1972. And then, because NASA wants to make clear this is not flags and footprints, Artemis V is scheduled before the end of 2028, 2 crewed lunar landings in the same year. The turnaround between Apollo 11 and Apollo 12 was 120 days. NASA is explicitly referencing that tempo, not trying to match Apollo, operating at Apollo speed while building something Apollo never attempted, a permanent presence. Now, let me explain why the South Pole specifically. This is not a symbolic choice. The South Pole of the Moon contains permanently shadowed craters, regions that have never seen direct sunlight in billions of years. In those craters, water ice has accumulated over geological timescales. That water ice is not just water. It is oxygen to breathe when electrolyzed. It is hydrogen for rocket fuel. It is the resource that makes long-term presence on the Moon sustainable without shipping every ounce of consumables from Earth. China understands this. They are planning their own South Pole mission. The South Pole of the Moon is the high ground of the new space race, and NASA is finally racing toward it with a plan that might actually get there first. Now, the construction plan. 3 phases, 7 years, $20 billion. Phase 1 runs from 2026 to 2028. The objective is to establish reliable high-cadence access to the lunar surface. 25 missions in 3 years, 21 lunar landings, 2 crewed, the rest robotic, delivering infrastructure and technology demonstrations. This is the prospecting phase. Before you build, you find. Before you extract, you verify. The tool doing that verification is the Viper rover, a golf cart-sized vehicle that has been built, tested, and sitting in a warehouse waiting to be delivered to the Moon for years. 2027 is finally that year. Viper arrives on a Blue Origin lander and begins mapping the South Pole for confirmed deposits of water ice and volatile materials. This data determines where the base gets built, not where it looks good on a rendering, where the resources actually are. Alongside Viper will be 2 lunar terrain vehicles, 1 crewed and 1 autonomous, each capable of covering 900 kilometers of the lunar surface. They move equipment, level ground, and do the unglamorous work that makes everything else possible. And then there are the rocket drones. NASA calls this vehicle Moonfall, based on the Ingenuity Mars helicopter platform but using small rocket thrusters instead of propellers because there's no atmosphere for propellers to push against. Each drone covers up to 50 kilometers in a single hop. They go where rovers can't. The tops of mountains, the edges of deep craters. For the first time in history, flying vehicles operating on the Moon. Phase 1 also introduces nuclear power. The Moon's day and night cycle is brutal. 2 weeks of sunlight, 2 weeks of total darkness at -200 degrees Celsius. At those temperatures, electronics freeze and die. Solar power works beautifully for 2 weeks and delivers nothing for 2 weeks. You cannot build a permanent base on a power supply that disappears half the time. The solution is radioisotope thermal generators, a radioactive element actively decaying, releasing heat continuously regardless of whether the sun is visible, preventing critical hardware from freezing during the long dark. NASA has been using RTGs since the 1960s. The Voyager spacecraft still draws power from RTGs launched in 1977. The technology is proven. Scaling it for a moon base is the engineering challenge. Phase 2 runs from 2029 to 2032. 27 launches, 24 landings, the transition from exploration to construction. 6 new rovers arrive, but these are not exploration vehicles. These are construction machines. Excavators that move rock and soil, level ground, dig trenches for power cables and pipelines, the foundation work that makes Phase 3 possible. One vehicle in Phase 2 deserves specific attention, a pressurized mobile habitat developed by the Japanese Space Agency in partnership with Toyota. 15,000 kilograms, an apartment on wheels. Astronauts work inside in short-sleeved shirts in a pressurized shirt-sleeve environment. It travels at 3.5 kilometers per hour, operates for 150 hours in total darkness, and has a 10-year operational lifespan. This is a rover you live in while traveling across the lunar surface for multiple days at a time. Power in Phase 2 comes from 2 sources: solar panels on tall poles connected to large battery systems, and nuclear fission reactors generating hundreds of electrical power, supplying multiple assets simultaneously and covering the base during the 2-week night. By the end of Phase 2, the power, communications, mobility, and habitat infrastructure are all in place. The moon base is ready for people to move in. Phase 3 begins in 2033 with no projected end date, because the end date is when permanent human presence on the moon is as unremarkable as permanent human presence on the International Space Station. A rotating crew of 4 people living on the moon for 28 days per mission, multiple connected modules powered by nuclear fission generators, 8,000 kilograms of food, water, and air delivered every month. And in Phase 3, NASA begins in situ resource utilization, using the moon's own materials rather than shipping everything from Earth. Water extracted from shadowed craters is split into oxygen for breathing and hydrogen for propellant. The moon begins to supply itself. Then comes 3D printing, taking lunar dust and melting it into a pourable material that builds the first genuinely permanent structures on the surface, not assembled from components shipped from Earth, grown from the material underfoot. This is the moment the moon stops being a destination and becomes a place. Isaacman said something that I think is more important than any technical detail in this plan. He said the real key objective of Artemis is not to build a moon base. The real imperative is to inspire the next generation of scientists and engineers, the young people who will accomplish things in their lifetimes that we would genuinely believe to be impossible today. But those kids will never do that if they don't have the motivation to try. And NASA hasn't given them that motivation for a very long time. Every mission in this plan is equipped with high-definition cameras live streaming to Earth. Every rover traverse across the South Pole visible in real time. Every rocket drone hop over a crater edge. Every moment of a crew living on the moon for 28 days. All of it broadcasting continuously to anyone who wants to watch. Not as a PR exercise, as a deliberate strategy to make a generation believe again in what reaching beyond looks like. The Chinese are building their own lunar program with their own South Pole ambitions running on a parallel timeline. The first country to establish permanent infrastructure at the South Pole writes the rules for who gets access to those water ice deposits, where the refueling infrastructure gets built, and what the governance of the cislunar economy looks like for the next 100 years. America spent 50 years pointing its rockets downward after Apollo. The plan announced in March 2026 is the first technically credible, strategically honest attempt to change that in half a century. Gene Cernan said we shall return. It took 53 years, but the return is not a single landing, not a flag and the regolith. The return is a base, a permanent, continuously operating human outpost on the moon, built from its own soil, powered by its own resources, with rotating crews living lives on another world as a normal thing that humans do. That's what ignition means, not a launch, a beginning. Subscribe because there's a lot more coming, and I want to hear from you in the comments right now.